Now, apart from the functions that are available directly, there are other functions which are available but which have been kept in a separate place, or what we call as package. Now, a package is a way by which we group together certain functions, just like a folder in our computers. So we use folders for what? To group the files. Similarly, a package is an element in which we group related functions. Okay, so first we have to get it, bring it into our environment. So import math. Yes, now once we have imported, we can know what all is there by using the dir command, dir function. Yes, so you notice after the initial sum functions, you have lot of additional functions. Let's look at some of them one by one. Now, you can't directly say CEIL of 3.56. It will give you an error. It will say name ceil is not defined. So what we have to do is we have to say math.ceil of 0.56. So basically there are two functions, math.floor 3.56. So ceiling is one integer and floor is another integer. So here floor is 3, let's say, and the ceiling is 4. So in between what, all the rational numbers are there, which are basically decimals between 3 and 4. Then we have factorial, say 5 factorial. Now again, we can't directly access it. We have to say math.factorial 120. 5 times 4 times 3 times 2 times 4. Trunc, math.trunc, which is short for truncating, or truncating also means cutting off. So truncating, let's say 3.56. What would it do? It would directly cut off the fractional part or decimal part. Math.exp of a number, say 4. What it will do is it will give us the e to the power of that number. Math.e. E is defined in math. So math.e to the power of 4. Yes, 54.5981500. Okay. Now the to the power of that double star is also available as a function. E, 4. Again, math.e, because e is defined in math. The difference between power and exponent is that exponent will always give e to the power of. You can't change that. Math.sine of, let's say, math.pi by 2 is 1. Math.cos, math.pi by 2. What is this? It's supposed to give you 0, but it is not giving you 0. So that brings us to the trickiness of floating points. Here if you look at this number 6.123239957366766 times 10 to the power of minus 17, right? So which is as good as saying 0. Yes, but to a large extent there will be approximation, because beyond a certain point these numbers have to be stored within a constrained memory, right? Say for example, if 32 bits are used or 64 bits are being used, however many number of decimal places there are, they have to be fit into a specific number of bits. So in the process, some roundings will happen, and because of which there will be some unexpected results. So you need to be aware of. Naturally, tan, math.tan. Again, let's say math.pi by 2. Another very interesting is hypot, which will give you the hypotenuse of a triangle given the other two sides. So math.hypot, say 3, 4, because we know this is the Pythagorean triplet. So 5. Now, if you notice, this is giving us a float. So again, you need to be aware of what it is returning, whether it is returning a int or a float. Okay, in many situations what happens is we require to convert radians to degrees and degrees to radians. So let's say radians, convert angle x from degrees to radians. So let's say 90 degrees, we want to convert it 1.57. Okay, so let's see what is pi by 2. Yes, now let's convert math dot degrees, convert angle x from radians to degrees. So let's give the previous one itself, 90 degree. Yes, whereas if you do the same thing but don't give it as math.pi by 2 and give it as this number 1.57 5707 96326794896, will you get 90 degree? Yes, we are getting, but don't depend on it. There might be, if you have a lot more digits, you might get some approximations. It's always better to use the constants if they are available. Okay, GCD, math.gcd, that is greatest common divisor, or HCF, highest common factor between two numbers. So 20, 4 will give you 4. Math.gcd of 10, 4, 2. Math.gcd of 9, 2, 1. Okay. Now, apart from these, you have logarithmic functions. Some of the functions which are important is INF, whether a number is infinite or not. Is nan, whether it is a number or not a number. This will come at certain points in time. Okay, so I think you got the idea. You need to be aware of this. Even if you don't remember how to use these functions, at least you should be aware of something like this is available, right? In most of the editors that you use, you will have this functionality. Math dot, if you wait for a few seconds, it will give you a complete list, right? It will give you a complete list, and then you can either click on it or you can type it. Now, the moment you open the bracket, it will again give you some help. Truncates the real x to the nearest integral towards 0. It will also tell you how many variables are required, right? So here x is there, so only 1 is being expected. Okay, so these are all the functions. Now, apart from this, you also have other packages. Now, many other packages are available from Python itself and from third parties also, which will give you very specialized kind of or niche kind of set of functions. Okay, I think that's enough for now. Bye.